its detailing and NAT as well. So we'll just discuss briefly about the IPsec, but we're just focusing upon the NAT-T. So because the bootcamp has been scheduled only for the NAT-T. I think already you are aware of IPsec. So how IPsec has been designed and how it works. So people who is taking the Palo Alto course, or CCNA, the IPsec class has been already covered from Karthik, I think, right?
No, bro, not yet
Yes, yes.
completed, bro.
It's not yet
June 4th batch,
completed.
bro. June 4th, yeah.
Okay, fine, fine. So I'll just go through the quick brief regarding the IPsec, and we'll just discuss about the NAT as well. Okay.
Yeah, sure. Thank you.
So generally, like anyone aware of the IPsec. So what is IPsec in term of IPsec means no one. So fine. So I
Generated with tunnel.
sorry. Yeah, yeah. Go ahead.
Between generate the tunnel between, for example, Harvard to Bangalore.
Okay. So just a simple of building the tunnel in between the two locations. You mean right?
Yes, yes.
Yeah, that's correct. So IPsec in terms of IP in the sense Internet Protocol and SEC means security. It's a suite of protocols used secure the IP communications. So by using hashing algorithms, encrypting the data, authentication and hashing, I can say. So it has been defined with the three terminologies, which is confidentiality, integrity, authentication. So confidentiality, it means the data no one should not see, like the data should be disclosed to the particularly with the two peers. So no one should not, like no one should not allowed to see the data. And integrity in the sense, so the hashing the data which cannot be modified. Okay. And coming to the IPsec, we have two modes, which is the main mode and the aggressive mode. Okay, guys, can you hear me?
Yes,
Yeah,
yes,
bro.
bro.
Audible, audible.
Yeah, yeah. So we have two modes, which is main mode and the aggressive mode. So in main mode we have two phases, phase one and the phase two. So where phase one in the sense, using for the management purpose, so for the communication between the two peers, and phase two, it's only for it is been getting built for the two peers for real time traffic, I can say. Okay. And in this IPsec, so basically we use two protocols, which is AH and ESP. AH in the sense authentication header, ESP in the sense encapsulating security payload. AH will works on the protocol number of 51, I think, and ESP, it works on the protocol of 50. Okay, so these both can be used in the both modes, which is we have two modes, which is transport mode and tunnel mode. Okay, in tunnel mode or transport mode you can use these two protocols and you can build a IPsec. Okay, and let's quickly jump onto the phase one. So I as I mentioned in the phase one, so we have two
A
protocols.
screen.
No, so
Okay.
far. So do you want me to share the screen, because I don't have any PPT, so I'm just discussing briefly. So if you want, I can just share my screen and I can open the PPT, or not PPT, Paint I can open for you.
Yeah, yeah,
Okay,
just open a paint and show how
just
it will.
give me a moment. Okay, let me just share my screen. So is my screen visible now?
No, not yet, bro.
Uh, just a moment. I'm sharing my entire screen. It's uh right now.
Yes,
Yeah.
yes.
Yeah,
Yeah, audible.
yes,
Yeah, yes,
yes.
it's visible.
Okay, so generally, let's take this is the tunnel. Okay, and not this one. Let's take a line again. Okay, so let's take as someone mentioned. So between the two locations, so we are just forming the tunnel. So currently, let's assume this as a phase 1, okay, and this is the phase 2. So by using the in IKE, so by using the IKE only, so in IK in the sense in internet key exchange, by using this IK only we will form the tunnels by using the phase 1 and phase 2. Phase 1 generally uses for the management traffic between the two peers. So this is the, let's take, this is the Hyderabad location and this is the Kurnool location. Okay, so we have multiple types of IPsec VPNs. Let's take a remote VPN. By using the VPN, we will connect, and site to site. Generally, we will just proceed with the site to site IPsec. So site to site in the sense the IPsec tunnel should be formed between the sites. That means, as mentioned, Hyderabad and between the kernel, we are forming the tunnel. Okay, so by using this IKE, we are forming the IPsec tunnel between the two peers. So as mentioned, we have two modes, which is main mode and aggressive mode. Okay. In aggressive mode, sorry, in main mode, we have two phases, which is phase 1 and phase 2. Sorry, I'm not that much good in the paint or drawing. Okay. So just assume like this. So in phase 1, we have 6 messages, and in phase 2, we have 3 messages. Okay. In coming to the aggressive mode, we have 3 messages. And so what does these six messages consist of? So
Yeah,
as
yeah.
mentioned, right?
Sorry, Arsha, I want to interrupt you here.
Yeah,
See,
yeah,
guys, here in main mode there will be a no phase one, phase two. In phase one itself, we have main mode and aggressive mode, and in the phase two we have quick mode. Okay, I just want to correct here.
yeah, yeah,
We
sure.
have two modes, phase one. Sorry, we have two phases, phase one and phase two. In the phase one itself, we'll be having main mode and aggressive mode, and in the phase two, we'll be having quick mode. I just
Yeah,
want to
this is the
correct.
quick mode. Yeah, yeah.
Just
I'm
proceed.
sorry. Yeah. So in these 6 messages, as mentioned, right? Uh, we'll call as Hadl. So HADLE. So where this hashing authentication, Diffie, Hellman exchange, where the tunnel lifetime. So what and all encryption methods will be used. So upon all the 6 messages, it will be covered, including this phase 1 with the 6 messages. So in these 6 messages, 4 messages are widely open. We can able to see that 4 messages in the Varshini captures, and 5 6 are the encrypted. We cannot able to see. Okay, so generally, based upon these 6 messages, the negotiations will happens. Upon that, the phase 1 will get built, and based upon the same negotiations, phase 2 should also build. So phase 1, as mentioned, it is used for the management purpose, and phase 2, this the second the tunnel, which is used for the real time traffic. So the data can be transferred by using this phase 2 here. Okay, so this is just kind of a brief overview, and Karthik will explain you further in the IPsec class. So why I have explained you this, this main mode, this, we have phase 1, phase 2, right? So in phase 1 or phase 2, we have some messages. So based upon that, we'll be just, getting over to the NAT-T concept here. Okay, NAT-T and NAT-D, T and D. So generally NAT-T in the sense NAT traversal, and D in the sense discovery. So I think you people are aware of NAT, right? So anyone, like, can you explain about NAT? Like, what is NAT in terms?
A network address
Converting
translator.
the yes
Convince
private
provider to
network to
provide a
public
maintain
network.
elastic.
So changing of one network into another network, changing of
Connect-
the address, one address to another address. Let's take it's private to public or public to vice versa, right? So generally, let's just clear. I'll just take the new page.
To protect internet net from outside network.
Sorry, I didn't get.
To protect internet inside a IP address from outside world.
I didn't get. You're talking about, like, you're having any query or you're telling something.
No, no, no. I'm telling that
Yeah,
to
NAT in the
protect in
no, no, not protecting. So changing of one address to another address, like from private to public or public to private. So that simply terms called as a natting. Okay, so as we discussed, we have two locations here, right? Which is Hyderabad and Kurnool. So whether it might be a phase 1 or phase 2. So we have 6 messages, I said, right? Let's simply discuss with the phase 1. We have 6 messages. I'm just going through the lines as a 6 messages. Okay, So please note that, one two messages, like some payloads, these everything, like kind of negotiation will happen. So six messages will, uh, cumulating of six messages will call as a negotiations. So negotiations will happen in the six messages. So one two messages and three four are open wide. As I mentioned, we can able to see that, and five six are encrypted. We can able to see that five six messages in the workshop captures. And in one two messages, the NAT packet will happen. Like we have several negotiations will happens, like, ISA camp versions and payloads will be happening. That is further detail will explain by the Karthik. But we'll, apart from that, so there is NAT payload will comes, like, let's take from Hyderabad to Kurnool, the tunnel has been built. We don't know because we are going through the internet. So this is completely an internet world. So this is, the tunnel has been built, and this is the private network, and this is the private network, and this is completely public. Let's change the color. So this is public network. Okay. So in this public network, to secure our data, what we are doing, just we are building a tunnel from one location to the peer location. Correct? Guys, are you following me?
Yes, yes.
Yeah. So here, in internet, we are not sure. Like we are having many devices, L3 devices. Let's take as a routers. So to identify the any of the L3 device in between, so let's take, I am taking the Palo Alto as example. Any of the vendor, we have they will support the NAT-T. Okay. And in Palo Alto, I'm just taking as an example of Palo Alto here. Okay. In Palo Alto, we have the feature called, uh, not a feature, to identify the NAT device. So in internet, there might be any L3 device, so over the internet, so we'll be having this NAT option. So we can just enable this NAT. So in that case, what will happen, uh, in one two messages, so first message, let's take Hyderabad as an initiator. The one who initiate the, you know uh, uh, for forming the tunnel will call as an initiator, and the peer will be called as a responder. Okay. So in Hyderabad tunnel, this is, let's take this is as an initiator. And in initiator, apart from the payloads, we'll be sending the NAT payload as well. Okay. Not payload, like, we can tell as a NAT, it's kind of a non payload itself. Okay. So that payload has been responded by the responder from the second message. So either we can enable the NAT as well. Let's take, I'm building the tunnel between the two Palo Alto firewalls with the different locations. Okay. So here one two message, we can clarify that we are identify, like we are using the NAT. And coming to the three four messages, we can identify that through the NAT discovery, we can identify that whether the NATing has been done or not. Okay. So in third message, the Hyderabad, you know uh, Palo Alto firewall, what it will do, in the payloads, it will use the NAT payload to discover the NAT actually. Okay. So when I have sent the data, any IP of the ports has been changed to know that the NAT-D payload will be used where the source IP and the destination IP and the peer, which is kernel source IP and the source port. That means source IP and the peer. Okay, source port, destination port, and destination IP and source IP. So in accumulating of source and destination IPs and source port and destination port. So the initiator will create the hash key. In at the same time, parallelly here also it will be having the hash key as like as Hyderabad location. Okay. So apart from the payloads, it will send the NAT-D payload to the responder, and the responder will decrypt these, payload, and it will be identified like when the same data. So it hash key I can say. Okay, based upon in the NAT-D, using this, for this particular source IP and source port, destination IP and destination port, the hash key has been generated. Let's take the hash key as a ACD. Okay, the same hash key has been generated by using the four terminologies, which is source IP, destination IP, source port, and the destination port. So here, let me change the color for better purpose. ACD. So the ASCII is the ACD. So let's take when the initiator will send the third message to the responder, it will decrypts all the data in the NAT-D. In the NAT-D payload, when it will decrypts all the data, right? So the accumulating of all the data will comes the output as a ACD. In that case, it will be identified as there is no NAT-T device present in between. Okay, if there is, let's take if ACD will be comes as the output after the decrypting from the responder as a B Z. So let's take I'm just telling you that it is a ASCII. Okay, so A B Z. So generally, what is the initiator side? What is the ASCII? Can you just let me know what is the ASCII we are identifying in the initiator side?
ACD.
ACD, right? So while sending the the NAT-D payload to the responder, so the outcomes, like while decrypting this payload, if the outcome comes as a ABZ, that means so someone has done some changes. So this responder will will comes to knows that, so it will respond, it will in 3 4 messages parallelly they will exchange the messages. So they will come to know that when the outcome will be output will be same as the current output. So ACD is the normal output as ASCII. If ACD is the same output, then they device will comes to know that there is no L3 device will be present. So there is no kind of natting is not required, I can say. And if there is a output difference comes to the ACD, in that case the device will assumes that so NAT one of the L3 device is present in between over the internet, and it is performing the natting, like that you can assume. Okay. So far you have, do you have any doubts? Hello, team, are we okay, or should I proceed, or do you have any doubts so that we can discuss?
You can proceed.
Okay, let me just clear this as well, or let me just open a new tab.
Ricardo. Ricardo.
Okay, so as mentioned, right, I'm using the site to site tunnel between the two locations, and I'm taking the same vendor, which is Palo Alto firewalls on the both sides. Okay, I'll do one thing. So I'll just take you one Cisco reference document, so for your better understanding. Okay, and just give me a minute. Okay, let me just be on mute for a minute. So is my screen visible, right?
Yes, sir. Yes.
Okay. So I'm just taking as a reference as this Cisco document. So generally, uh, okay. So the tunnel has been formed from site one to the site two. Okay, and this is the internet we can say, and this is the NAT device in between the two peers which has been present and over the internet. Okay, so and my screen is clear, right?
Yes, yes.
Okay.
Yes.
So we are forming the tunnel in between the 172.16.1.1 and 200.1.1.1. Okay, and which is natting is required over here. So and the 200 IP is public, right? If I'm not wrong. Hello.
Yes.
Yeah. So here I have mentioned, right. So some messages will be there, like six messages will be there. So these are all these things like encryption, hashing, what is the group called, and we have the lifetime as well, like the tunnel lifetime, how much of the tunnel should be alive, like that. So all these negotiations will happen in the six messages generally. So this is a command like in the Cisco you can execute. So you can just get the information over here. Uh, and as I mentioned, right, so generally let's go with the first message. Okay, so which is the tunnel has been formed between 172.16.1.1 to 200.1.1.1. Okay, so here I can say under the ISAC camp, if you check just the payload, so you can just refer the vendor ID 13. Okay, so it is sending the NAT-T payload as well. Okay, are you following me?
Yes.
Yeah, so including the all the messages I mentioned, right? So and in meanwhile, you can clear note that SPI should be different for the first message, and the rest of the things SPI is same. SPI in the sense it is a security parameter index. Okay, and while coming to the payloads here, it will add the NAT payload over here, and it will sense the responder. The same way it will get the response as well. You can see the vendor as a 13 and the RFC as a 3947. So it is supporting the NAT. Okay, and you can just go through this document. I'll share it later. It's a public document only for your reference. And coming to the third here, so here, so first and two messages what I mentioned, so NAT has been discovered from the one and two messages from the two peers. Okay, coming to the third message and the fourth message, NAT-D will happen. So NAT discovery. So where cumulative of source IP, destination IP, and the source port and the destination port. So ASCII has been created. That ASCII should be same with the both peers. So if there is a difference in the ASCII after the decryption, that means the peers will assume that so natting was happened. Okay. So if you could see, that's the same way in the ISAC camp. Under ISAC camp, you can see the payload NAT-D payload. So these are the two ASCIIs. Okay, you can follow me here. This is the one hash key and this is the another hash key. So the same way responder is also responding. You can see that from 172.16.1.1, this is our remote pair and this is the no, this is our current pair and this is the pair one, remote one. And the same way we are getting the response from the 200 to the 172. Guys, are you following me?
Yes, yes.
Yeah, so this is the third message and this is the fourth message. If you want, I can just scroll up once again. So our peer on the topology is the 172.16.1.1 and 200.1.1.1 is the our peer location, which is kernel. So in first message, RFC, a NAT payload has been sent and it is responded with the NAT payload as well. And here in third message, it is sending the NAT payload as well. Okay, with the accumulation of ports and the IPs. These are the two hash keys for the two peers. Okay, and the same way it is responding with the same payload. Okay, so that means it is just acknowledging. We are getting the acknowledgement from the responder. The responder in the sense which is kernel. Okay, so in this case, the NAT will performs in the IPsec. So generally, if the hash key will be differs for the from the current key, that means we can assume that there is NAT happens. And we have headers, like we have H header and ESP headers, that will be explained by the Karthik in further class. Okay. uh, and the UDP port number which is sending from the source location is the UDP 500. So how come this NAT-D will identifies that NAT should be performed between the two peers or whether should be dropped or not? So if 4500 port is not used, generally it will uses the ESP header or AH header. And as I mentioned that, let's go with the ESP header. Okay, so in ESP it will be had the normal IP data and the TCP header and IP header which is source and the destination. Apart from that, it will be get covered by the one new IP header with the ASP header and the trailer. Okay, so while comes to this NAT device, when this data has been sent to this 200, in between it will passes through over the internet. So in internet we have the L3 device which is the a router, I can say. So this router will just checks the L4 header, which it will confirms that which is 4500. That means it is assuming that, so this is traveling to somewhere else to the destination, and based upon the 4500 port, it will just reroutes to the destination. That's it. It will just it won't even perform anything. It will just check the 4500 port and it will reroutes to the peer destination. Then peer destination from the public IP, it will the decapsulation will happens for the respective headers. Okay. Hello team. Hello.
Yes.
Yeah, are you
Yeah,
getting me
yeah, yes,
or
sir.
do you have any queries?
No.
So maybe it's something new for you guys. So that's why maybe you can just go through this document. I'll share you some information as well in the respective groups for CCN and PCNSE groups. So once you get the IPsec topic clearly, briefly, then you can clearly come to know what are all these payloads, and why we are using these six messages, and what is this phase one and phase two, and aggressive mode and quick mode. All these things you can come to know once you will be done with the IPsec. Then you can clearly able to got to know what is this NAT-T. Okay. I think this is the thing about the NAT-T here. So if you have any queries, we can discuss, and just give me a minute. Okay. Let me just stop my screen share. Yeah. So far, do you have any queries, or or did you understand like what I have explained regarding the NAT-T, or do you want me explain one more time, or do you have any further queries? So you can just let me know so I can I can tell you regarding that.
Yes, explain me one more time.
Okay, fine. Uh, so this is the tunnel we are building, right, from Hyderabad to Kurnool,
I
correct?
think Arsha, can you please share your screen? I think you have stopped sharing screen.
Yeah, yeah, yeah. Just a moment. Okay. Now is my screen visible now?
Yes.
Okay, so I'll just take this document as a reference. So simply, Yashwant, here NAT-T, how to identify the NAT-T in the sense, in 1 2 messages, the devices will sense the NAT-T payloads. Okay. So, and in 3 4 messages, what they will do, they will send the NAT-D payloads, which is NAT discovery. So why 3 4 messages they will send the NAT-D in the sense, they will just identify and they will come to know that whether the NATing is present or not. That's it. Okay. So 1 2 measures are only for supporting the NAT, whether the device will support the NAT or not, and 3 4 are only 3 4 if in the case if in case if they supports, and 3 4 will be there for discovering the NAT device, like which is in present in between the in over the internet, I can say. Okay. So simply based upon the hashing value only, the devices will come to know in the 3 4 messages that the NATing NAT device has been present in between or not. Okay, as I mentioned right before, I'll go through the paint again. So it has been sent the NAT-D payload. Okay, we have some respective defilement keys as well. Apart from that, I'm not going through this, but I'm just focusing on the NAT-D. So cumulating of the source port and the destination port and the source port, sorry, source IP and the destination IP. So it will generate the hash keys. Okay, so these hash keys will send over the NAT-D payload to the peer, which is kernel. Okay, so we cannot call it as a peer here. I'm just for your reference, I'm calling it as a peer, but we can call as initiator and the responder. Okay, the traffic which has been sending like from beginning, it will call as the initiator, and who is receiving will call as a responder. Okay, so in third message, what it will do, it will send the NAT-D payload to the responder, and responder will decrypt the this payload by using the key. Okay, then it will get some output. Okay, I'm sending some ash and blah blah blah, and when it will decrypt, so when the responder decrypts the traffic with the key, it will comes know some output. Let's take as a 123. Okay, and here the payload as the hash key of the 123. So both payloads at the both peer side, if the output is same as a 123, that means the devices will comes to know that there is no natting happening. Okay, and in that case natting should not require anyways. But if they come to know that there is natting happening, in which case when the NAT-D payload decrypts from the any of the device, the outcome will comes as a 125. That means it is changing from the current payload. So actual payload ASCII is 123, and at the responder side we are getting the output as a 125. That means someone modified the data. So in that case, they assume that they'll fix that in the 3-4 messages that NAT-D will get discovered, and it will be acknowledged from the responder side. Okay.
Okay.
H1, did you understand?
Yes. First of all, NAT-T is for to check the device is compatible or not for NAT communication. After that, NAT-D is from sender initiator to
Confirm.
conformer.
Yeah.
It sends the hash keys. Uh, Based on that hash keys, the whatever the received device is there,
Yeah.
that device is decrypts the messages.
Exactly. Yeah.
Without that key, it can't help for decrypt the message. For that, it sends it.
Yeah, with the key. So when you get the messages in the sense payloads, I can say. So
Yes.
that messages will be getting from the responder. It will be having in the third message. It will be having some Defi Helmin key, and I'm just not focusing on that. I'm just going through the NAT-D only. Okay, apart from these, it will sense the NAT-D as well. So once it will get descripts from the responder side, you'll get the output, the hash key. Okay, so if the hash key is same as the peer one, in that case it will confirm that there is a no natting happening. The same way we can able to go through the Cisco document, it's clearly mentioned.
Okay, I got it. In case nothing is happened, the 123 key is changed to 125. Right.
Exactly, you're correct.
Then it acknowledges to the initiator.
Yeah, yeah. So the same, no, the same way the responder also responds to the initiator with the same NATD payload. Okay.
Okay.
Yeah, and 5 6 messages are that is for authentication key purposes. Those are generally encrypted. You cannot able to see in the Wireshark captures. And so far we have not set up the lab for this NAT. What we will do once the IPsec will be done for you, right? For you CCNA or PCNSE people. So we will set up the lab for the NAT as well. We will be taking one L3 device over the internet, and we will set up a lab, and we will explain you with the packet captures. And meanwhile, you can just go through this reference document for your information, and we will set up a lab once the topic is done, and we will show you with the live packet captures. Okay. And so far, what you get the questions on the NAT, in the sense that you interviewer will ask that why NAT will comes into the picture, okay, and how the NAT will be come to know by the devices like that. So in the 3-4 messages, NAT payload will be sent across the devices, and if the ASCII will be differs, in that case, the device will confirms that NAT is performing like that. You can answer. Okay, this is the very important question, especially for the experienced people. So through the IPsec, related to the NAT, this is the question you can expect. Why NAT will be used, and what is NAT and what is NAT difference, and how the hashing will be done. You can expect the questions from the interviewer. Okay. And so far, if you have any queries, we can discuss. And not in case, I think Karthik, we are good, and we can we wrap up the session, or do you want to add any more thing?
Yes, guys, do you have any questions on this?
Yeah, NAT-T we are taking in this scenario, it will support IPsec VPN. For that, we are taking NAT-T.
No,
Is it?
no,
No,
not like
actually,
that.
how it will be like, we are forming IPsec tunnel between two peers, right? Means one firewall or router in one location. We are forming an IPsec tunnel between other firewall and which is located in other location, right? So if we have any NAT device in between, okay, if we have any NAT device between our IPsec sites, so then we are going to use NAT-T, okay. So that is the main concept. Whenever the NAT device present in between our peers, then we have to use NAT-T, okay. Why means, so as Arsha mentioned, whenever you are sending, okay, the IPsec is based upon L3 net, okay. It basically on say forming and secure tunnel on L3, right, network layer. But NAT device is an L4, okay. So whenever you are sending L3 traffic over L4, so L4 will not accept that L3, right? So in that case, what we are going to do is we are going to enable NAT-T on both the sides. So whenever you are enable the NAT-T, so what happen means whenever you are sending IPsec messages, what the initiator will do means initiator will add extra L4 header, okay, extra L4 header with UDP port number 4500, okay, with source and destination port 4500, and encrypt our IPsec messages in that new L4 header, okay, and it will send through the internet, and whatever the NAT device in between we have, right? So NAT device will receive this, okay, whatever the data that we send from the IPsec one of the peer, and it will decapsulate that L4 header first, okay. It will decapsulate that L4 header, and it will send our IPsec, okay, whatever the IPsec messages that we have, it will send over it will send to our peers, okay. So basically, the important thing here is, in order to process our IPsec packets over the NAT devices, we have to enable the NAT on both sides, okay. That is the concept of NAT. Understood?
So, so
Yes.
yeah. So I mentioned, right. So this is the ESP header. So based upon the two protocols, you can form the IPsec tunnel, which is H and the ESP. But H in between, in the sense, it will perform the authentication and the hashing. But coming to the ESP, apart from that, it will perform the encryption as well. So it will hide the original data, original header, and it will add the one new header, and the this is the ESP header generally. Okay, and the ESP trailer also will be having here, and this will add the new TCP header, which will be with the port of 4500. So when any of the NAT device in between, let's take NAT device, I'll tell as a router. So any of the one router in internet that comes to know by using this IP, not IP, sorry, with this port number. So when it's assumed that as it receives the packet, this header completely and when it will decrypt this TCP header, and it will comes to know that it is a 4500. That means this is a uh, ESP header, and then it will just read out to the responder, I can say. Okay, so generally this is huge thing like this IP sync, but this is very very important topic in the security uh, terminals, I can say. So you will explain you in further details clearly from the scratch with IPsec as well. But as today is a boot camp, right? So we just want to focus on in brief with IPsec and detail with the NAT-T. Okay.
Okay. I
Yeah.
have a small doubt.
Yes.
We can configure IPsec and NAT T in single router, or we can use different routers. One is NAT-A, another one is
You,
IPsec.
I didn't get. Could you please repeat once again?
Yeah, you have to enable both on only single device. Wherever you are forming IPsec, you have to enable NAT on the same device.
Yes. Okay.
As I have taken right as a Palo Alto example, so you can enable the NAT option over here, and you need to enable the same here as well.
Okay.
Yeah. So in that case, it will support the NAT-T.
Okay.
This will be sending over the one two messages. So one should be for the initiator and the second message for the responder. Okay, like this.
Okay.
Yeah. So far, do you have any queries, people? I think let me just stop my screen and
Yes, guys, do you have any questions still? Do you have any need any clarification on this?
maybe some most of the people they might be having the 50% of the understanding because they are
Yeah,
not aware
actually,
of IPsec,
only
right?
okay. The June batch, okay, whatever the current batches are going on CCNA, they didn't completed IPsec, okay.
Okay,
So
okay,
might
maybe
be they are having some half of thing, okay. They have understood half of things. Okay, once we complete IPsec, okay, or once your CCNA completes, we'll also covering IPsec and NAT both on separate sessions. So in that time, I will also explain this NAT in clear. But this is a boot camp, right? This is for everyone. Okay, most of you guys are completed IPsec and NAT, so we have conducted this boot camp with IPsec with NAT. So that will be helpful for other people who completed an IPsec, right? So the June people, the June batches, don't worry about this. We'll see that in the IPsec as well. Okay.
Yes. In this communication in NAT, it uses the UDP header
it's
or
UDP. It's use the UDP. Yeah,
oh,
UDP with the port number of 4500.
yeah.
Okay, and you can remember that ESP protocol, protocol number as a 50 and H is a 51. Okay, so you don't worry, we'll provide all these details in clearly in our groups. Okay, I'll post it once the topic is done, so I can share you the several interview questions with the advanced and the basic as well. So far what you can face over the interviewer. So fine, I think I'm done from my end. So Karthik, if you have anything like you can add over here, or we can wrap up the session.
No, no. I think, guys, if you have any doubts, just let me know, or otherwise,
Or
we'll end off this
yeah,
session here.
you can reach out to us personally, or you can ping in the groups as well. So we'll if you have more queries, we can set up another session as well. Or if it is single kind of queries, I know I will reply over the group as well. Okay.
Generally, we are using
Yeah.
IPsec TCP connection end to end. In that general TCP header also it is using for communication by
Yeah. Here, just a minute. I think I have opened one page, right? TCSP header.
No, actually, IPsec will use only the UDP protocol, not TCP. Okay.
oh
Mm, As I mentioned, right, it will use the UDP 500 actually. Generally, it will use the USB 500. For over the NAT, it will use the 4500 port UDP. Okay.
that means UDP header is taking the payload of IPsec.
Yeah,
Is it
that's
right?
correct.
Yes. Yeah.
Okay.
So you can go through this document. I will be sharing this with you. Uh, and if you have any queries once after reading this documentation, and you can just reach update in the group. So we will assist you further with your queries. Okay.
Okay.
Yeah. Thank you, Tim. Thank you for the participation. Have a great day and happy weekend.
Thank you.